All right, these are our first set of notes for this week. It's notes number 20. We're learning about trigonometry. So kind of like geometry, but it's trigonometry. In your books, this is chapter 7, section 3, page 438. Please feel free to look in that page, follow along, because I do follow along with the book. Make sure you've got name, date, period. And this should all be written down already from our warm-up during class. So our essential question is, how do I use trig to find side lengths and angle measures in right triangles? So for today, we're focusing on the side lengths, and then the second set of notes for this week on Thursday or Friday, it'll have to do with finding the angle measures. So let's go and get started right here. This is really important to understand. Why are we doing this? The reason we even have trigonometry is to find missing side lengths of right triangles. So you'll notice that every triangle that we're working with, it's a right triangle. So use trigonometric ratios to find missing side lengths. Okay, and it might be a little confusing at first, but just keep trying and we'll practice and you will get it. But you probably haven't learned this before, and so anytime you learn something new that's different, it can take a little while to understand it. So here's the key concept from the book. Again, you guys pause as you need to. You might need to pause and copy it down, and that's fine. So our key concept on trigonometric ratios. There are 3 different types of ratios. And I'm going to do a lot of color coordinating of it. So the first one is called sine. So it looks like it says sin, but we actually call it sine. So for so, that's the sine right there. Okay. So sine is a ratio, and it always has to do with, like there's a top and a bottom number. So the top number is always the opposite. So I'll trace the O in purple, opposite. So from the big A, see how it's the big A there? From the big A, opposite would be right here. That's opposite from the A. So whatever that length of that side is, that would be opposite. And then hypotenuse will be H. And of course, the hypotenuse is always across from the right angle, that one. Okay, so I'm going to go ahead and write down now what the actual values would be. We don't know number values, but we do have letters. So for sine A, looking at big capital A from this angle, we go opposite over hypotenuse, little a over C. So that would be that ratio. So if I had actual values there, like just to say maybe it was like 6 over 10 or something like that, then that would be the ratio. Okay, and we'll do examples like that later. All right, so that is sine. Now let's move on to cosine. So cosine is, we remember it with c, the A is adjacent over hypotenuse. Cosine, cosine. Okay, I got to be careful with my colors. I don't want to confuse you. So I will use orange for adjacent. I haven't shown you adjacent yet. So adjacent means you're right next to, like the side that is right next to the angle A, capital A. So that would be right here. That would be adjacent. Maybe if I trace that side, that might help. And then it's over hypotenuse again. Remember, hypotenuse is still always across from the right angle. It's that one. Hypotenuse, and then remember A was the opposite. Okay, so let's go ahead and write down the ratio. What would the ratio be for cosine A? From A, I want to write the side lengths of adjacent over hypotenuse, orange over yellow. It would be B over C. You can tell it just takes a lot of practice to get the hang of this. Okay, so that was cosine. We remember it by c, adjacent over hypotenuse. Sine is opposite over hypotenuse. So if you remember so, c, and then toa, I know this is a lot, but if you can remember that, it's like your shortcut to help you remember the different ratios, what goes on top, what goes on the bottom. So sine is opposite over hypotenuse. Sine A opposite over hypotenuse. Cosine, A for adjacent, H for hypotenuse, and then tangent. Let's get to that one. I need another different color. Okay, so for tangent, A, TOA, tangent, I would do the opposite, which I used purple. And then I can look at the diagram. It would be the A over adjacent. And again, adjacent just means it's the side right next to it. Adjacent would be my yellow, or orange, sorry. Okay, so to get the ratio of what the two values would be, tangent A opposite over adjacent. So from the angle A, I'm looking at opposite side over adjacent side, A over B. And if you look, every ratio has a different, well, it would be different. We have A over C, B over C. So notice how they both have C on the bottom because that's the hypotenuse. But then we have A over B, which is the top here and the top here. So it's going to take some practice, like I said, but just try to remember TOA is the shortcut to try to know the ratios. S for sine, O for opposite, H for hypotenuse. C for cosine, A for adjacent, H for hypotenuse. TOA, T for tan, O for opposite, A for adjacent. Okay, and the A, like sine A, cosine A, tangent A, with that capital A, tells you which angle to look from. We could go and do all of these from the B angle. We could say sine B, opposite over hypotenuse, cosine B, adjacent over hypotenuse, tangent B, opposite over adjacent. So we could also look from angle B, but not C. We never do it from the right angle, only one of the other two angles. Okay, so we have some examples now. So like I said, it's going to be a lot of repetition so that you can understand how it works. Okay, there. Let me focus it again. Okay, so practice writing ratios. Use the given triangle to find the following. So we're not finding the side lengths. As you can see, we have 3 side lengths. It's 8, 15, and 17. And if we did, just so you know, if we did the Pythagorean theorem, a squared plus b squared equals c squared, this would work. It would be a right triangle. But what we're doing that's different for this section is learning these trigonometric ratios. So I'm going to look up, I'm showing the upper part from the key concept. Sine L would be my opposite. I'm going to do purple again. Opposite over hypotenuse, which was yellow, like that. So from L, angle L, I'm looking at, see here how it has sine, opposite over hypotenuse. So from L, opposite over hypotenuse. And remember that hypotenuse is always across from the right angle. That's how you know. You could even write like an H there. Like for so, how it's an H. So, ka. Well, TOA doesn't have the H. Okay. So anyways, all you got to do is write the ratio. It's 8 over 17. I didn't really leave myself much space, so I kind of have to write it weird. But that one is going to be 8 over 17. Cosine. I used too many colors. I lost my pink. Oh, I think I put it back. Okay. So cosine, I'm trying to make it match up here, is adjacent over hypotenuse. And I had adjacent marked with orange. And again, I'm looking from L, like that. And so all I have to do is look at adjacent over hypotenuse, 15 over 17. Okay, and then tangent is TOA, O, so opposite over adjacent. So looking from L, I see opposite was 8 and adjacent is 15. So again, I'm using the same three numbers, but I'm putting them in different spots, top and bottom, in different orders. And that's, I mean, it's very specific. It's opposite over hypotenuse for sine, adjacent over hypotenuse for cosine, and then opposite over adjacent for tan. But that's how the trig ratios work. All right, so now we're going to do from m. So now I'm going to look at the different angle. So again, we can't look from from K, but we can look from M. So now I'm going to be looking, I'm just going to use pencil just to show from M. So I'm looking from M now this time. So for sine L, it was 8 over 17 because that was my opposite over hypotenuse. But looking from M, my opposite is now 15, 15 over 17. So you can see the numbers change a little bit. All right, and then cosine from M. So now I'm thinking, okay, I'm looking from M. I need to do cosine, which is adjacent over hypotenuse. Adjacent is 8, hypotenuse is 17. Oops, let me use pen. 8 over 17. And then tangent. Tangent from M. Tangent is always opposite over adjacent, no hypotenuse. So from M, I'm looking at opposite over adjacent, 15 over 8. And you can see that the ratios are different depending on which angle you're looking from. Sine L is different from sine M because L is a different angle than M. Cosine L is different than cosine M, again, because they're different angles. And tangent is different also. In fact, if you look at it, you kind of see that tangent is flipped over, and cosine and sine, the ratios are flipped. Or not flipped, they're switched. All right, so let's practice that again with this one. I'm going to go a bit quicker. And I don't think I'll do as much color coding. So hopefully it all makes sense as I go. So since I can't see this part up here anymore, I'm going to rewrite so, ka, toa. And I'm just going to go over that with you guys again as I find each one. So is sine. So I'm going to look from L. First, I'm going to look from L. Sine is OH, opposite over hypotenuse. So I left more room on this one so I could write neater. So for sine L, my ratio would be opposite over hypotenuse. So always notice which one's the hypotenuse. I always draw an arrow across from the right angle so that I know that this is my H. Okay, so sine is from L is opposite over hypotenuse, so 2 over 4. And you don't have to reduce it. You might think, oh, that's 1/2. Just keep it as a 2 and a 4 for right now. So cosine from L is adjacent over hypotenuse. So from L, adjacent is 2 radical 3, 2 square root of 3, over hypotenuse, which is 4. And so you just write it like that. And if you had to put it in a calculator, which you might later, just put it in like that. And then over 4. And then we've got tangent from L. And that would be, TOA. Okay, so TOA, OA, opposite over adjacent. So from L, I'm looking from L, opposite over adjacent. 2 over 2 square root of 3. All right, so now I'm going to do all of that, but now I'm going to change where I'm looking from. I'm going to look from angle M. So here's M. I'm going to start with sine. Sine is so, OH. O over H. So from M, opposite over hypotenuse. Opposite is 2 square root of 3. Hypotenuse is 4. And then I'm going to look at cosine of M. So from M, cosine is ka, A-H. So I'm going to put A on the top, H on the bottom. So from M, adjacent is 2, hypotenuse is 4. 2 over 4. And then tangent M is from M, I'm going to do O over A. O is opposite, A is adjacent. A is always next to it. So 2 square root of 3 over 2. And then I can check all my different ratios. They should be different because I'm looking from L and then I'm looking from M. And again, we would never look from the right angle. We would never look from K, only the other two angles. So I can see my sines are different, the cosines are different, the tans are different. So I'm pretty sure I did everything right for this. Well, actually, I know I did it right, but you guys know what I mean. So anyways, we're going to go on to the next page and do some actual examples with calculations. So pause if you need to, otherwise we're going to move on. All right, so we're going to do some examples now. Go ahead and write this down. I put again, so Toa at the top, and you can tell if you spell it wrong, it's not going to come out right. It has to be SOHCAHTOA. That way you know which ratio to use. So now use trig ratios to find distance. Find the measure of side W to the nearest tenth. So here we see it is a right triangle. We have an angle of 54 degrees. So now the angle is given. Instead of saying like sine A or cosine B or something, we actually have an angle measure, and I'll show you what to do with that. I know my hypotenuse is 17, but I'm trying to find this side length. So what I want to do first is identify what I know. Seems a little blurry. Okay, so again, I know that I have, I'm not going to go too crazy with colors, but I do know that I have my hypotenuse of 17. I want to label it as H. And from this angle, you always maybe circle the angle that's given. From the angle, this would be O, it's opposite. It's not adjacent. The adjacent isn't given. So the only two I have is opposite and hypotenuse. I have O and H. So if I look at these at SOHCAHTOA, that tells me which one to use, because otherwise I wouldn't know if it's sine or cosine or tangent. So since I have an angle, I measure, or I circle the angle, and then I identified hypotenuse was across from the right angle, and that was given to me. And the one I'm trying to find is my opposite. So I'm going to go ahead and use sine. And then this is how you set it up. Sine, put in the angle. Sine 54 equals, and then you do O over H. The O is the one I'm trying to find, so I'm going to put W. H is 17. So one more time, the way that I set it up is I had to identify the angle, I circled the angle, and then I show which one's the hypotenuse. The other one that's given, it's a W, is my opposite. So since I have O and H, sine is the only one that has O and H. So, okay, so if I was given adjacent instead right here, then it would be cosine. Or if the hypotenuse wasn't given, if it was just opposite and adjacent, O and then A, then it would be tangent. All right. Again, this just takes practice. So I'm going to go ahead and show you guys in the calculator how to do this. So in my phone calculator, it's like that. So I have to do sideways, and then I get the other options. You should be able to get this on your Chromebook, and you could even like search calculator. So notice that you do have, okay, I have to cover it, that you do have buttons for sine, cosine, and tangent. So we will be using those today. So I basically just have to put sine 54, and then I can put that value in for sine 54. So it's 0.809. I'm going to just round it to like the thousandths place. So 0.809. 0.809 equals W over 17. And I hope you guys kind of remember how to get W by itself. Since it's W divided by 17, you always do the inverse operation, you do the opposite, and I would multiply both sides by 17. And then what happens is the 17s cancel out like that. Okay, so in the calculator, I do still have that value. You'll have a more accurate answer if you just put times and then the 17. Otherwise, it rounds it differently. But if your answer is close, then that's the main thing that matters. So it does say round to the nearest tenth. The tenths place is the first after the decimal. So I have to look 1 to the right, which is a 5. If it's 5 or higher, you round up. So that would be 13.8 is approximately equal to W. And then I would just switch it around. And I don't have units like inches or meters or centimeters, so just put the value. So again, make sure you're rounding to the tenths place. It's the one right after the decimal. Look 1 to the right. If it's 5 or above, you round up. If it's 4 or below, you would keep it the 7. But since it's a 5, you round up. Okay. So again, you guys, this is just going to take some practice. So I'm going to move on to the next one. We'll have a few to practice. Okay, so this one, you can tell again, it is a right angle. So it's a right triangle. We can do trig. This angle is 28 degrees. This side is 1.0. You could just write 1, but it's exactly 1.0. And then the other side given right here is W. This is the one we're solving for. So just like we did on the last one, I'm going to circle the 28 degrees. So I always circle the angle given because it's like looking at it from this angle, from this perspective. I don't have hypotenuse given. It would be across from the right angle, but there's nothing written there. So what I do have is across opposite. Opposite is 1.0, so I'm going to put an O for opposite, and then adjacent is W. So looking at, it's at the top of the paper now. Looking at SOHCAHTOA, if I only have an opposite and an adjacent, which one would I use? So you can see that's why I go through this. Circle the angle, put the O, H, or A, depending on what's given, and then you'll know which to use, sine, cosine, or tangent. So you can tell it's tangent, T-O-A, tangent, opposite over adjacent. So that's how I'm going to set this one up. So it would be tan 28 equals opposite is 1, 1.0, and then over adjacent, which is W. So what you could do, in the last one I found sine 54 first, you could do tan 28 in the calculator and put a value there. But to be more exact, I would rather do isolate the W first. What I'm noticing is this is kind of like a proportion. So if you're good at solving proportions, this might be good for you. So whenever you have a value and it's not over anything, like even over here, it's over 1. Anything, any whole number, any value is over 1. So you can cross multiply, which that doesn't really change anything. 1 times whatever, it's going to stay the same. But then what you'll get is W times tan 28 equals 1. I'm just going to put 1. It's 1.0. It's 1 times 1, which is 1. But then I'm seeing what I need to do to get W alone is I then have to divide by tan 28. Divide by tan 28. And then they cancel. So I'm doing all this work so that I can just do one calculation in the calculator. I have to do 1 divided by tan 28. So I'm going to go ahead and do that right now to show you guys. I would press 1 divided by, press your tan button, 28 equals. Round to the nearest tenth place. So it's 1.88. I need to round to the first 8, so I look 1 to the right. It's an 8. It's 5 or above, so I do round up 1.9. And make sure, well, it's not that big of a deal, but I am rounding, so I should do my wavy equal signs 1.9. And then always check and make sure that makes sense. If I have one side length of 1 and one that's 1.9, sure, that makes sense. It's not negative and it's not like a crazy number, so it makes sense. Okay, so let's move on to the next one. And this one, it's kind of hard to see it, but this is 33 degrees for the angle. So put 33. I've got a right angle, so I know for sure this can work, trig can work. Across from the right angle is the hypotenuse, so I do have an H for this one. I just have to figure out what's the other side, if it's an O or an A. And again, that helps me determine, am I doing sine, cosine, or tangent? So from this angle, the W is my A for adjacent. So I will be doing cosine. So again, just to show you guys, I'm looking at SO, CA, or TOA. And since I have my A and H, I know to do CA or cosine. Okay, so I'm going to start setting up my, it is kind of like a proportion. So cosine, and again, that angle value is 33. And then it equals A over H. Adjacent is W over H, which is 4.5. And so I want to do this one like how I did the last one, where I kind of like just cross multiply. You can draw a 1 under it, or if you don't feel like you need to, you really are just multiplying across, but there's a 1 there so it doesn't change the W. So if you want to cross multiply, and then I'm going to have 4.5 times cosine 33 equals W times 1, which is W. So I just have to do that one calculation in the calculator. Or like I said in the first one, because you can still see it, I was going to show you, you could think about multiplying both sides by 17, or like here it was 17 to cancel. Here you could have thought about multiplying both sides by 4.5. There's more than one way you could think about doing it, but you end up still multiplying 4.5 times cosine 33. So anyways, in my calculator, I would do 4.5 times cosine 33. And then still round it to the 10th place, so it's 3.77. That 7 rounds it up to an 8, 3.8. So I'm gonna switch it also. W is approximately equal to 3.8. And then we have just one more. And you'll have problems like this to practice on Math Excel. So that way you can get a lot of practice doing this. All right, so here is our last one. It is, the hypotenuse is 300 inches. So now we have units finally. And then the angle that's given is 40 degrees. The side we have to find is W. So let me circle it. Here's the angle that we're looking at. I already said that's our H across from the right angle. And then the other one is W, and that's adjacent. So if I have an A and an H, I have to think SO, CA, TOA. Let me just write it again. This is what I would do. Me being the teacher, I still would always write it down just to be careful and see which one it is. So if I have an A and an H, it's cosine. So you could do that for every problem just to make sure you're doing it right. So from here, I would just set it up. I would write cosine 40 equals A over H. A is my W. H is 300. It's just like that last one we did. Okay, so I'm going to go ahead and, again, think about cross multiplying or multiplying by 300 to both sides so that it cancels. Whatever makes more sense to you. We did cross multiplying, so I'll just show that again. 300 times cosine 40 equals W. W times 1 is just W. So I'm going to go ahead and put that in the calculator and see what I get. You guys should be practicing this too. Make sure you are practicing using these buttons. Okay, so I would do 300 times cosine 40. And then I get 229.81. I'm rounding to the 10th place. Oh, you can't see it. Sorry. I'm rounding to the 10th place, which is an 8. I look 1 to the right, which is a 1. So I stay. I don't go up. I stay. 229.8. So W is approximately equal to 229.8 inches. Okay, so that's how we do trig. And you'll practice in Math Excel, and just know that you'll probably definitely need to use scratch paper like how we've been doing. Just make sure you're writing it down and trying your best to get these ratios correct. Make sure you do your 3 questions on the left and a summary.